So it wasn't in the previous video, but today we're going to talk about the distance formula. So the distance formula is a formula to calculate the numerical distance between any 2 points on the coordinate grid. So those points will be x1, y1, and x2, y2, which you would have seen in the slope formula, meaning point 1 and point 2. So the distance formula is a version of the Pythagorean theorem. So if you're not familiar with the Pythagorean theorem, it is this formula. It says a squared plus b squared equals c squared. And the way it works is you have a right triangle. Let's say the measurement of one side is 3 and another side is 4. We can find the measure of c, c being the hypotenuse, meaning the side across from the right angle. So the way we would find that is we would say that c squared is equal to a squared plus b squared. We would say c squared is equal to 3 squared plus 4 squared. So c would be equal to the square root of their sums. So c is equal to, in this case, the square root of 9 plus 16, and c would be equal to the square root of 25, so c equals 5. So on a coordinate grid, it might be easy to just count 1, 2, 3, 4 horizontally, or 1, 2, 3 vertically, but you can't really count diagonally because the measure of any particular diagonal length is not going to be the same as just counting by ones. So we need a method for doing that diagonally. So the distance formula comes from the distance formula at this point. So it says c is equal to c is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. In other words, this is your a squared, and this is your b squared. This c is really d, meaning the distance between the 2 points, and the square root is really when you would take the square root in the formula. So for instance, if we had a point on the coordinate grid, and let's just place it here at the coordinate will be 4, 2, and another point over here at 1, 1, negative 2. And I wanted to find the distance between those 2 points. What I can do is I can kind of make an imaginary right triangle with a measurement of 3 across and 4 up. And I could use the Pythagorean theorem, and I'll see that this is 5. So I could do 3 squared plus 4 squared equals 25, and the square root of that is 5. But using the formula, we're just going to calculate that all in one shot. So the distance is going to be equal to the square root of x1 minus x2, so that's 1 minus 4 squared, plus the distance between y1, which is negative 2, minus y2, which is 2, squared, which is going to be the distance here, which will be negative 3 squared, and negative 4 squared. Now do note that these are negative values, but it doesn't really matter because when you square them, they will become positive. So the distance here is 3, but this gave us negative 3. It just has to do with the order in which I picked the points to go. Similarly, this gave us a negative 4, but again, it's just the order in which I put the points. But 3 squared and negative 3 squared and negative 4 squared are still going to be positive numbers. So we'll get the distance is equal to the square root of 9 plus 16. Distance will equal the square root of 25, and the distance will equal 5. So one way or another, you get the same measurement using the distance formula or the quadratic or the Pythagorean theorem, which you might prefer. I actually use the Pythagorean theorem quite often when I'm looking at the graph of the 2 points, but just given the points by themselves, it probably makes more sense to use the distance formula with the given coordinates of point 1